Welcome to our advanced training on the Plotly chart editor in Plone CMS. This session builds on the basic training and introduces you to sophisticated features that will help you create more complex and impactful data visualizations using the Volto Plotly Charts add-on. Let's explore how to add and position annotations in your chart. I'll start by clicking the Add Annotation button in the toolbar. I'll enter some simple text for our annotation. This could be any explanatory note you want to add to your visualization. Now, let's understand the positioning system. Plotly gives you two different reference options. You can position elements relative to the canvas or relative to the axes. Canvas positioning is fixed to the physical chart space, while axis positioning is tied to your data coordinates. I'll set the horizontal position to 0.5, which means 50% of the canvas width. Notice how when I drag the chart around, the annotation stays fixed at exactly the same position on screen. That's because it's anchored to the canvas itself, not to any data point. Now watch what happens when I change the horizontal reference to the x-axis. The 0.5 value now represents a specific x-coordinate in your data. When I drag the chart, the annotation sticks vertically since that's still referenced to the canvas, but horizontally it moves with the data points. Finally, I'll change the vertical reference to the y-axis as well. Now the annotation is fully tied to the data coordinates in both dimensions. As I drag the chart, you can see the annotation moves both horizontally and vertically, staying with the exact same data point regardless of how we pan or zoom. The same positioning principles apply to all elements that can be placed on your chart. Here I've added a rectangle shape, positioned relative to the canvas in both dimensions. As you can see when I drag the chart, the rectangle remains fixed in place, just like our annotation example. Now I'll change just the horizontal boundaries to be relative to the x-axis. Notice how the rectangle now moves horizontally with the data while remaining vertically fixed to the canvas position. This mixed positioning gives you tremendous flexibility in how your visual elements behave during interaction. Here we have a horizontal bar chart showing trade balances for EU countries. Notice in the Style Axis section that our y-axis is set to Categorical. This means each country is assigned a sequential value, 0 for the bottom country, 1 for the next, and so on up to 26 for the topmost country. Understanding this numbering system is crucial for precise positioning of elements. Let's add an annotation to highlight Germany's impressive trade surplus. I'll click the Add Annotation button in the Annotate Text section. I'll set the text to plus 195 to represent Germany's net income in billion euros, which is the highest value in our dataset. For horizontal positioning, I'll set it relative to the x-axis and enter 195 as the position coordinate, matching the data value. For vertical positioning, I'll reference the y-axis and set the coordinate to 26, which corresponds to Germany's position as the topmost country. I'll set the vertical anchor point to middle to properly align the annotation with the center of the bar. The annotation appears slightly offset to the right, so I'll adjust the horizontal position to 189 for better placement. A better approach is to set the horizontal anchor point to right, keeping the horizontal position at 195. Finally, I'll change the text color to white for better contrast against the green bar and reduce the font size to 13 pixels to ensure it fits comfortably within the bar width. Now let's use shapes to enhance our visualization. I'll add a rectangle shape by clicking the Add Shape button in the Annotate Shape section. I want this shape to span the full width of our chart, so I'll set the horizontal boundaries relative to the canvas with a start point of 0 and end point of 1, effectively covering from left to right. For the vertical boundaries, I'll keep them relative to the y-axis. Since I want to highlight all countries with a negative trade balance, I'll set the start boundary to negative 0.5 and the end boundary to 14.5. The value 14 corresponds to the last country with a negative balance, and I'm adding 0.5 to position the rectangle slightly above the bar. Now I'll match the fill color to the orange used for the negative value bars, but set the opacity to just 10% so it subtly highlights this region without overwhelming the data. When I pan the chart, notice how the shape moves vertically with the data points but stays fixed horizontally across the canvas. Let's add another shape for the countries with positive trade balances. Again, I'll set the horizontal boundaries relative to the canvas from 0 to 1. For vertical positioning, I'll reference the y-axis again, with start point at 26.5 just above Germany and end point at 14.5, covering all countries with positive balances. I'll color this shape the same green as our positive value bars and set opacity to 10% for consistency. When I pan the chart, both shapes maintain their relationship to the data points vertically while spanning the full width of the canvas. As a final touch, I'll remove the line width of both shapes, eliminating the borders for a cleaner look that doesn't distract from the data. Let's enhance our chart with branding by adding the EEA logo. I'll click the Add Image button in the Annotate Image section and select the EEA logo from my files. Initially, I'll set both width and height to 50, which represents 500% of the image's original dimensions since positioning is relative to the canvas. However, watch what happens when I change the positioning to be relative to the axes. These values now act as coordinates on our data scale. I'll position the logo at 150 horizontally and 4 vertically, then set both anchor points to middle and center for proper alignment. As I pan the chart, notice how the logo moves along with the data points. It's worth noting that although the height value of 50 far exceeds our y-axis range of 0 to 26, the image doesn't extend beyond the chart boundaries. This is because the image aspect ratio is set to contain, which intelligently scales the image while preserving its proportions. Now let's create a chart with multiple axes to compare related but differently scaled data. I've prepared a dataset with annual measurements of average temperature and total fuel emissions. First, I'll add a line trace mapping year to the x-axis and fuel emissions to the y-axis. This will use our primary y-axis. Next, I'll add a second line trace, again with year on the x-axis but now using average temperature for the y values. For this trace, I'll specify a new y-axis. This creates a dual-axis chart with fuel emissions on y1 and temperature on y2. Let's address some formatting issues. Notice that our years display with thousands separators. To fix this, I could change the x-axis range type to Categorical and set tick spacing to linear with a step size of 10. However, there's a better approach that preserves Plotly's automatic tick spacing. I'll revert the x-axis range type to linear and simply disable the thousands separator by setting separate thousands to no in the tick labels subsection. For the second y-axis, I need to enable the tick labels by clicking Show in the y2 section. Now, we have a proper multiple axis chart showing both data series with their appropriate scales. Finally, let's configure the legend to make the chart more understandable. I'll enable the legend and position it at the top left corner of the chart. Then I'll rename the traces with descriptive labels, total fuel emissions, and average temperature Celsius degree, so viewers immediately understand which line corresponds to which dataset. This dual-axis approach is perfect for visualizing related variables with different units or scales while maintaining their temporal relationship. Let's explore how to create side-by-side subplots for comparing related data. I have a dataset comparing material exports from Romania versus the broader EU. First, I'll create a horizontal bar chart mapping Romania exports to the x-axis and material to the y-axis. This forms our first subplot. Next, I'll add a second horizontal bar chart mapping EU exports to the x-axis and keeping material to the y-axis. For this second chart, I'll configure it to use x2 for the x-axis. Now we have two charts, the first using the x1, y1 coordinate system and the second using x2, y1. To arrange these charts properly, I'll go to the subplots section. For the first subplot, I'll set it to span from 0 to 50% of the grid width while maintaining its full height. For the second subplot, I'll set the x overlay to none so the x2 axis doesn't overlap with x1. Then I'll position it from 50% to 100% of the grid width. I don't need to adjust the vertical position since both charts share the same y-axis. Now let's refine the appearance in the style axis section. For the y-axis, I'll hide the grid lines to reduce visual clutter. For x2, I'll show the grid lines and also display the tick labels, positioning them at the bottom for better readability. To clarify what each chart represents, I'll add annotations. For the first plot, I'll add Romania exports with horizontal positioning relative to the canvas, anchor point set to auto, and position at 0. The vertical positioning will be relative to the canvas with the anchor point at bottom and position at 1. For the second plot, I'll add EU exports with similar settings, changing only the horizontal position to 0.5 and the horizontal anchor point to left to align properly with the second chart. This side-by-side layout provides an immediate visual comparison between Romania's exports and those of the entire EU, making it easy to spot patterns and differences across materials. Let's explore how to use the sort transform to organize your data visually. I'll add a sort transform to our existing chart that compares material exports. The sort transform is powerful because it rearranges your data based on values, making patterns immediately obvious. I'll select the first trace and add a transform, choosing Sort from the drop-down menu. Then I'll select which column to sort by. In this case, I'll sort by Romania exports in descending order. Notice how both our subplots remain properly aligned after sorting. This is a key benefit of our shared y-axis design. Since both charts use the same y-axis, when we sort one trace, the materials remain perfectly aligned across both visualizations. This is an important consideration when designing multi-panel visualizations. If we had created two completely separate subplots with distinct coordinate systems, x1y1 and x2y2, we would need to explicitly add matching sort transforms to both traces to maintain alignment between the panels. When working with related data across multiple panels, deciding whether to share axes isn't just about layout. It affects how transforms propagate across your visualization and ensures your comparisons remain valid. Let's explore how filter transforms can be used to highlight patterns across different time periods. I'll work with our fuel emissions dataset to demonstrate this powerful feature. I'll start by creating 3 identical bar traces, each mapping year to the x-axis and total fuel emissions to the y-axis. Without filters, these would all show the same data, but we'll use transforms to tell a more nuanced story. For the first trace, I'll add a filter transform targeting the year column. I'll set the operator to less than and the reference value to 1900. This filters our first trace to show only emissions data from 1850 to 1899, the early industrial period. For the second trace, I need to isolate the 20th century, so I'll add 2 filter conditions: year less than 2000 and year greater than or equal to 1900. This creates a trace showing emissions from 1900 to 1999. For the third trace, I'll add a single filter with year greater than or equal to 2000, capturing our most recent data from this century. Each trace now displays a different time period with its own color, creating a visual history of emissions growth. To emphasize the concerning upward trend, I'll go to the Style General section and change the color scale from categorical to sequential, using a gradient from livid yellow to bright red. This color progression visually reinforces the increasing environmental impact over time. Filter transforms are invaluable when you want to segment data while maintaining consistent axes and scaling across all segments, allowing for meaningful visual comparisons. Now let's explore how to use split and aggregate transforms to analyze patterns across categories. I'm working with a global dataset containing population and life expectancy statistics for countries around the world. I'll start by creating a simple scatter plot, mapping population to the x-axis and life expectancy to the y-axis. Each point represents a country, giving us a global view of how these variables relate. To add more analytical depth, I'll go to the Transform section and add a split transform, grouping the data points by continent. Watch how this immediately enhances our visualization. The points are now color-coded by continent, and the legend shows each continental group separately. This simple transformation reveals regional patterns that weren't visible before. Let's take our analysis a step further by adding an aggregate transform. I'll group by continent again, but this time I'll specify how to aggregate each axis. For the x-axis, population, I'll set it to sum. This calculates the total population for each continent. For the y-axis, life expectancy, I'll choose average to show the mean life expectancy by continent. Our visualization now condenses from many individual country points to just a few aggregate points, one for each continent. This transformed view gives us immediate insights into continental differences, showing which regions have the largest populations and how that correlates with average life expectancy. These transforms are powerful for distilling complex datasets into meaningful summaries while maintaining the visual clarity of your original chart type. Let's look at a common challenge with pie charts: controlling the order of the segments. Here I have a pie chart showing status data with categories of good, poor, bad, and unknown. You might notice that the segments aren't displayed in the logical order we'd expect: good, poor, bad, unknown. That's because, by default, Plotly sorts pie chart segments by percentage value, placing the largest segment first and continuing in descending order. For status data like this, the default sorting doesn't make sense semantically. We need the segments to follow our conventional status progression regardless of their sizes. The solution is straightforward. First, I'll go to the pie trace settings and change the segment's order to unsorted. This tells Plotly to stop sorting by percentage and instead respect the order of the data as it appears in our dataset. Next, I need to ensure the data itself is in the right order. I'll go to the data grid and manually rearrange the rows so that good comes first, followed by poor, then bad, and finally unknown. Once the data rows are in this order and the pie chart is set to unsorted, our visualization now displays the status categories in their proper logical sequence, making it much more intuitive for viewers to interpret. This technique is valuable whenever you need pie chart segments to follow a meaningful, predefined order rather than being sorted by size. Let's explore how to harness the full power of Plotly through direct JSON configuration. I'm going to demonstrate this with a complex table chart showing countries and their pollutant emissions. In this visualization, I want each cell to be color-coded based on the pollutant emission levels for each country. The first column containing country names should have white cells, while the pollutant column should have color-filled cells reflecting their values. While the Plotly chart editor gives us extensive control through its UI, some advanced features require direct JSON editing. Cell fill colors in table charts are a perfect example of this limitation. I'll start by creating a basic table trace, mapping our dataset columns appropriately through the UI. But to achieve the cell coloring effect, I need to access the JSON editor by clicking the JSON button in the interface. First, an important step. I'll disable automatically extract data sources because we'll be adding configuration that's incompatible with the automatic data handling. Leaving this enabled would break our data table when we add custom properties. Now I can add the custom configuration. Under the cells property of the table trace, I'll add a fill object. Within this, I'll create a color property, which takes an array. This array defines fill colors for cells by column. For the first element of this array, our countries column, I'll specify white. For the subsequent pollutant columns, I can either use a single color string to apply the same color to an entire column, or provide nested arrays of colors to specify different colors for each cell in the column based on the row. This level of customization is only possible through the JSON editor and illustrates why understanding Plotly's JSON structure is essential for advanced visualizations. When you encounter limitations in the UI, remember that the JSON editor provides access to the full range of Plotly's capabilities. Congratulations! You've now mastered the advanced features of Volto Plotly charts, elevating your data visualization skills to a professional level. Throughout this training, you've learned how to create sophisticated visual annotations and drawing elements, work with multiple axes and scales to display related metrics, design complex grid layouts with coordinated subplots, transform your data through filtering, sorting, splitting, and aggregation. Access the full power of Plotly through direct JSON configuration. These advanced techniques allow you to craft visualizations that go beyond basic charts, telling richer data stories and providing deeper insights to your audience. Remember that great visualizations balance technical sophistication with clarity and purpose. As you apply these advanced features in your own projects, focus on enhancing understanding rather than adding complexity for its own sake. Thank you for participating in this advanced training. Happy charting!